sklearn, cluster, spectral biclustering. Description: Spectral biclustering is a clustering algorithm that aims to find subclusters within both rows and columns of a data matrix. It's particularly useful when dealing with data that exhibits biclustering patterns, meaning there are groups of rows and columns that are highly correlated with each other. It leverages spectral graph partitioning techniques to identify these biclusters. Inputs: data: a 2D array representing the data matrix where rows correspond to data points and columns correspond to features. Outputs: row labels: an array of integer labels for each row, indicating the cluster assignment. Column labels: an array of integer labels for each column, indicating the cluster assignment. Steps: construct the similarity graph. The algorithm first constructs a similarity graph based on the data matrix. This graph represents the relationships between rows and columns. Calculate Laplacian matrix. The Laplacian matrix is computed from the similarity graph. This matrix captures the connectivity information of the graph. Perform spectral decomposition. The Laplacian matrix is then decomposed using singular value decomposition (SVD). This decomposition yields eigenvectors and eigenvalues, which are used for clustering. Assign cluster labels based on the eigenvectors and eigenvalues. Rows and columns are assigned to clusters. The assignment process usually involves thresholding or using a clustering method like k-means on the eigenvector space. Metrics: biclustering quality. The quality of the biclustering results can be assessed using metrics like the normalized mutual information (NMI) between row labels and column labels. Silhouette score. The silhouette score can be used to evaluate the quality of the cluster. Assignments for both rows and columns. Visualization plots. Heat map. A heat map of the data matrix can be visualized with row and column labels color-coded according to their cluster assignments. This helps identify biclustering patterns. Dendrogram. A dendrogram can be used to visualize the hierarchical relationships between rows and columns within each cluster. Fine-tune parameters. N clusters. The number of clusters to find for both rows and columns. Method. The method used for assigning cluster labels. Possible options include stochastic iteratively refined cluster assignments and k-means use. K-means clustering on eigenvectors. Random state. The random seed for reproducibility. Uncertainty methods. Bootstrap resampling. Repeat the biclustering process multiple times with different random subsets of the data to estimate the stability of cluster assignments. Challenges and fixes. Challenge 1: finding the optimal number of clusters. Choosing the right number of clusters can be challenging. Sample use case that resulted in challenge 1: trying to find the best number of clusters for a dataset with weak biclustering patterns. Fixes to challenge 1: use a range of cluster numbers and evaluate the biclustering results using metrics like a silhouette score or NMI. Explore other methods like elbow method or silhouette analysis to help determine the optimal number of clusters. Challenge 2: handling noise and outliers. Noise and outliers can affect the biclustering results. Sample use case that resulted in challenge 2: working with a data set containing noisy data points. Fixes to challenge 2: pre-process the data to remove noise or outliers. Use robust methods for similarity graph construction or Laplacian matrix computation. Consider applying dimensionality reduction techniques before biclustering to reduce noise and improve performance.